When a modern super heavy lift vehicle erupts from the launch pad, it releases more concentrated energy than almost any other machine built by humans. SpaceX's Starship uses a cluster of 33 Raptor engines, generating 7,000 tons of thrust. China's Long March 9 blueprints show 30 YF-215 engines, delivering an identical 150 tons to low Earth orbit. With the development of the Long March 9, China enters the super heavy lift category, creating a second parallel architecture for mass-to-orbit missions. Over the last decade, SpaceX's Falcon 9 normalized the idea of flying a rocket, landing it, and flying it again. In 2014, the Chinese government ended the state monopoly on space, triggering a wave of private startups designed to mimic the commercial agility of the West. This chart shows China's total number of orbital launches by year. Look at the steep upward curve of successful missions, starting at 19 in 2015 and reaching 65 by 2024. Beijing integrates this high-frequency launch model into a broader macroeconomic strategy, prioritizing market capture over individual scientific milestones. SpaceX deviates from traditional aerospace materials, using welded stainless steel and high-pressure methalox engines to enable rapid, ship-like reusability. China has traditionally relied on the highly successful, expendable Long March legacy workhorses. However, they recently completed high-altitude vertical takeoff and landing tests to validate recovery techniques. At the same time, a group of domestic commercial startups, often called the Five Little Dragons, are launching their own liquid-fueled rockets, directly adapting the proven Falcon 9 architecture to drive down the cost per kilogram to orbit. Landing a rocket on its tail is rapidly becoming the minimum requirement to participate in the commercial launch sector. SpaceX operates on a hardware-rich, iterative cycle. They prioritize building prototypes rapidly, flying them, and accepting they might explode to gather real-world flight data. China's state sector runs on a philosophy of programmatic stability. They lean on decades of legacy data and meticulous sequential planning to ensure a vehicle performs flawlessly on its maiden flight. One method is tuned to break old rules and iterate rapidly. The other guarantees national prestige, seamlessly integrating new rockets into existing state infrastructure. To fund the enormous capital requirements of deep space hardware, SpaceX developed its own massive self-sustaining revenue stream, the Starlink satellite internet constellation. China answers this with what analysts call a sovereign commercial nexus. Instead of relying purely on private capital, Beijing funnels massive state resources into its commercial startups. This financial backing allows these companies to build and deploy national mega constellations, like the Guowang project, at a fraction of the cost faced by Western firms. Rockets require constant capital. The entity that endures this race will likely be the one with the most resilient financial engine driving its assembly lines. SpaceX optimizes its super heavy hardware for one extreme metric: maximizing mass to orbit. The entire architecture is geared toward the logistical requirements of colonizing Mars. China's focus is much closer to home. They are executing the Sovereign Lunar Path, a highly structured schedule designed to land humans on the lunar surface by 2030 and construct the permanent International Lunar Research Station. Targeting the moon requires vastly different landers, orbital mechanics, and supply chains than targeting Mars. Right now, SpaceX commands a stark technical lead in absolute payload volume and turnaround time. This chart visualizes a trend aerospace analysts call redshift. It shows U.S. launch capacity scaling at a steady rate, while Chinese launch capacity is accelerating exponentially, closing the technical gap. The single trajectory of space exploration has split. Two heavily armed industrial bases are now racing to establish the dominant infrastructure for humanity's expansion into the solar system.